Hey, what's going on, you guys? Guys, once again, compliments for the new year, and welcome to another episode on the Incredible Academics YouTube channel. We are going to carry on with trig, and remember last time we were talking about compound angle identities. So this time around we're going to be proving identities. So prove the identities using what? Using the compound angle identities. Okay, so this is what we're being asked, and the first question is, so we're given an identity, so the sine of 180 degrees plus theta is equal to minus the sine of theta. I mean using a reduction formula, this is actually very much true, because if you check, 180 degrees plus theta is in which quadrant? I hope you said quadrant 3. In quadrant 3, which trig ratios are positive? Only 10, isn't it? And yeah, only 10, meaning that sine is negative, hence we've got the minus sine of theta. So, but we want to use compound angle identities to prove if this is actually real. So we just going to expand this, okay? So we're going to say, okay, the left hand side, right, is equal to the sine of 180 degrees plus theta, and that is fine. And now we need to expand, okay, the left hand side. How do we expand? Okay, we know we're going to have two products here. We're not sure as yet as to whether the trig ratios here are going to be identical or they're going to be different. Okay, but the question is, what's going to be the middle sign, plus or minus? Remember, when we're dealing with the trig ratio sign, signs don't alternate, okay? So now this is like the separator of the two products. The first product goes over there, and then another product is going to be here. So, but now here, are we going to have trig ratios that are the same or different? I hope you said different, because it's sine here that we're dealing with. So sine, cosine, sine, cosine. So now all we need to do is just to plug in the angles. For the first product, we maintain the order there, so 180 degrees theta. For the second product, we swap the order around 180 degrees. So we're done with the expansion. So now we just need to further simplify. Okay, now how do we simplify this? The sine of 180 degrees, the sine of 180 degrees, yes, how do we simplify that? Because we can rewrite the sine of 180 degrees. So sine of 180 degrees minus 0 degrees, okay, cosine of theta, plus the sine of theta and then the cosine of 180 degrees minus what? Minus 0 degrees, okay? But 180 degrees minus any angle theta, this is in the second quadrant, and we know that sine is positive in the second quadrant, so this is just going to simplify to what? The sine of 0 degrees and then cosine of theta, plus, so we're just applying a reduction formula right now. So, and then the sine of theta over there, the cosine of 180 degrees minus theta. Well, 180 degrees minus theta second quadrant, but in the second quadrant cosine is negative, so that's going to become minus the cosine of 0 degrees. At 0 degrees, you guys remember the graphs of sine and cosine? 0 degrees is right there, and this is where, remember, this is sine, and then that's your cosine. So at 0 degrees here, sine is 0. You can see that the curve is passing by the origin. So this is simply 0, and then the cosine of theta plus the sine of theta, and then minus the cosine of 0 here. It's 1. That's 1. So now our answer becomes what? Negative the sine of theta. Okay, I hope everyone is happy with that. Yeah, I mean, this is just the basic sine and cosine graphs. Yeah, at 0, one is has got a value of 0, the other one has got a value of 1. Cool. Let's look at another problem. Let's look at another problem which is slightly more interesting. Okay, so we are given what? The cosine of 360 degrees minus theta is equal to what? The cosine of theta. So now we need to simplify here. So as always, we go for the complicated side. So here you must conclude by saying this is equal to the right hand side. Proof done. So LHS is equal to the cosine of 360 degrees minus theta. Now let's use compound angle identities to simplify this. Okay, right. So the model sign is negative, so we're dealing with cos, so it's going to alternate. And when you're dealing with cos, you know we're going to have this. All right, yes. So 360 and then theta and 360 theta. Remember, you don't necessarily have to swap the order here, you know, when cosine is concerned. Even if you do swap the order, it's not going to make any difference. Okay, but it's very important to swap the order by this product when you're dealing with sine. Okay, right. So the cosine of 360, will go back to the graph. At 360 cosine is 1. At 0 and 360 cosine is 1. But sine is 0. So 1 here, cosine of theta plus the sine of 360, that's 0, sine theta. So now this simplifies to what? Just the cosine of theta, and this is equal to the right hand side. So we managed to prove the identity. Let's go right ahead. Now, I mean, I don't find these problems interesting anymore. Well, let's move on to different types of problems. I just feel like they're kind of repetitive, you know. So the exercise, so we not prove the identities, okay? Prove the identities. Identities. And this is without the use of a calculator. The use of a calculator. Without the use of a calculator. So the first problem that we're going to look at is the cosine of 45 degrees minus theta. Alright? Minus the sine of 45 degrees minus theta. And this is said to be equal to root 2 the sine of theta. I mean, once you start seeing 45 degrees, 60 degrees, 30 degrees, I mean, you know for sure there's going to be special angles, and the special angles, you need to draw the triangles, the two triangles that I showed you guys. Okay. Now the left hand side is like this: cosine of 45 degrees minus theta minus the sine of 45 degrees minus theta. Okay, that's the left hand side. Now let's break it down. So first and foremost, we're going to break this one down and then followed by that one. Cool. So we're going to have what? Plus cos 45 cos theta sine 45 sine theta, and then we break this one down as well. Minus, okay, it's important to put the parentheses. So the sine of 45 degrees cosine of theta minus the sine of theta, and then the cosine of 45 degrees. You see, this side we already have sine 45. We cannot have sine 45 again this side, so we must have sine being attached to the other angle, okay, which is theta. This side we only get cosine of theta, so that side it has to be cosine of the other angle. Do you understand? So that's how the sine compound angle operates. Anyway, let's go right ahead and simplify this. So let me see, cosine of 45 degrees cosine of theta. So now we need to figure out what is cosine of 45 degrees, what is the sine of 45 degrees, and obviously they are exactly the same. 45 degrees special angle, I mean that's easy to work with. So the two triangles, this is the triangle for 45 degrees, 45 degrees, 45 degrees, 90 there, root 2 here, 1, 1. That's the triangle that you guys need to cram. Okay, whenever they say anything of 45 degrees and you unleash this triangle, then you can just read off the values. So the cosine of 45 degrees, that's just 1 over root 2. Your calculator is going to say root 2 over 2. Okay, yeah, so that's how they're going to catch you that you use the calculator when you start substituting root 2 over root 2. Okay, but if you use the triangle, 1 over 2. So cosine of theta plus 1 over root 2, the sine of 45, and then sine theta. Okay, and then minus the sine of 45 again, that's 1 over root 2 cosine of theta, right? And then plus cosine of 45, 1 over root 2 sine theta. This is becoming a plus because there's a negative over there, right? So now let's try to collect like terms. You can see that here there's a plus 1 over root 2 cos theta minus 1 over root 2 cos theta. So those two there, they cancel out, eh? They cancel out. So what we're going to be left with is the sum of the two uh, 1 over root 2 and 1 over root 2, which is going to be simply 2 over root 2 the sine of theta. Okay, but this doesn't look like that. All right, so what we're going to do is we're just going to rationalize the problem. Root 2 over root 2, so that becomes 2 root 2, that becomes 2 root 2 over 2 sine theta. And the problem is done. This and that they cancel, so root 2 sine theta, which is equal to the right hand side. So we've managed to prove the identity, and this time around this was a little bit more interesting. We couldn't just predict what the outcome was going to be, which is what what keeps math interesting. Let's do one more problem, and I think that will be it for today. Okay, so another problem looks like this. I don't want to bombard you guys with too many things. Yes, I don't want you guys to overheat. Wait, so we've got the cosine of a minus 60 degrees plus the cosine of a plus 60 degrees. Plus 60 degrees, and this is said to be equal to just the cosine of a. Okay, so let's check if that is actually true. So left hand side is equal to that. I'm not going to rewrite that. I'm just going to expand immediately. So now a minus 60 degrees, so that's going to be cos a cos 60 degrees plus sine a sine 60 degrees, and then we are going to say plus cos a cos 60 degrees and minus sine a sine 60 degrees. Okay, so that's what we have, but you see we've got 60s here, so meaning that we need to construct the 60-30 triangle. 60 degrees here, 30 degrees over there, and 90. So yeah, I remember sine 30 is 1 over 2, so sine 30 opposite over hypotenuse, and the other side should be root 3. Okay, yes. So now that we've got this triangle, we can do the substitution. So the cosine of a, that's fine, but what's cosine of 60 degrees? What's the cosine here? 1 over 2, isn't it? Adjacent over hypotenuse. The sine of a, the sine of 60, I hope that's root 3 over 2, opposite over hypotenuse. Cosine of a, once again, we already got cos 60, which is 1 over 2, minus the sine of a, we already got sine 60, which is root 3 over 2. Root 3 over 2. Now let's do the simplification. Let's see, do we have any like terms? Okay, cos half, that just becomes cosine of a, but there's plus sine root 3 over 2 minus sine root 3 over 2, so the 2 they cancel out, so we're left with just this, so this is equal to the right hand side, and proof is done. And that's it, ladies and gentlemen. I think we've done more than enough, yeah. So until next time, don't forget to share with friends and family, let them know about the YouTube channel, and yeah, let's go.